For our last problem, number 5, we just need to determine if the following series converges or diverges, and again, make sure we know which test we're using. So our series is here. We have from n equals 2 to infinity. We have n factorial over the repeated odd multiplication, 1, 3, 5, up through 2n minus 1. So we want to check if this converges or diverges. When you look at this, you see factorial repeated multiplication, you should immediately think ratio test. So remember, for the ratio test, we're taking the limit as n goes to infinity of, we take the n plus 1th term times the reciprocal of the nth term. So we have n plus 1 factorial over 1, 3, 5, 2n minus 1. The next term would be 2n plus 1 of that one. So now we multiply by the reciprocal of the nth term, which is just this, but the reciprocal of it. So we're taking the limit as n goes to infinity of the absolute value of this entire thing. And remember, the ratio test says this converges if this value is less than 1. So let's see what we get here. Now everything in this repeated multiplication cancels out except for the 2n plus 1 that's attached to this one. And when you have n plus 1 factorial over n factorial, that's n plus 1 times everything lower. So this would cancel out and just leave us with n plus 1. So what does that simplify to? We have the limit as n goes to infinity, absolute value of n plus 1 over 2n plus 1. Now at this point, we don't need the absolute value bars anymore because n starts at 2 and goes greater. These are both positive. We don't need to worry about that. And we just have n plus 1 over 2n plus 1. How do you take the limit of that function? Well, at this point, those are both polynomials. Those are both degree 1. So all we need to do is think about what are the coefficients on the highest degree. For the top, we have 1. On the bottom, we have 2. So our limit here is 1/2. 1/2 is less than 1. So by the ratio test, we know that this converges. So we would say converges by the ratio test.